I have commented previously that I'm not happy about the fuel system on the bike. The main problem I have at the moment is this intermediate tank, which is supplied from the main fuel tank down this hose, through the tap and around and into here. And then from the bottom of this tank, it goes to the fuel pump, which is this item here. Now, the fuel goes up through the fuel rail, which is underneath the plenum chamber here, and then back past the regulator and into the tank. Now, this tank should, once you've burped all the air out of it, not have any air in it. No vapor locks, nothing. It should be just fluid. However, when it's running, for some reason there is air bubbles or some sort of vapor coming down this line and getting into this tank. Now, when the fuel inlet is connected directly to the tank, any bubbles that come out of here can go directly up into the tank. It's a pretty straightforward sort of a connection. When that's happening, the air bubbles can get out and the fuel can get in. However, to make things more legal and user-friendly and a few other things, I'll put a tap on it. Now that means the route for any air bubbles is a bit more up and down, and I don't think the air bubbles are getting out of the tank. So the concern is that the air bubbles will build up in the tank. They'll actually eventually fill up the tank down to the level where the fuel is actually being taken out and going to the fuel pump, letting air into the system and upsetting the fueling, because obviously you've got air bubbles going across the injectors. It's going to go lean. So what I've decided to do is put a line from this connection, which is just a 6mm bolt in the top. This is just to bleed off the air bubbles, which is what I've been doing previously. And this is going to have a connection to a line which goes across to this side of the bike, because the turbocharger goes on this side eventually. So I'm keeping a line which will have fuel and vapor up this side, and to a connection on the bottom of the underside of the tank towards the front and up high. So this will allow any air bubbles that end up in this tank to simply come up the line and hopefully just move off into the petrol tank. Now, any fuel that needs to go into this tank to supply the pump and the injectors should hopefully just flow freely into here with no hindrance by bubbles trying to come back out this line. They will go out the highest point. It's a bit hard to see, but the lid of this tank actually has a peak in it. So hopefully the air will come out of this tank, out of this point. The problem, of course, is making a hole on the underside of this tank. Now, petrol tanks hold petrol. Who would have thought? Full of vapor even after you've had the cap open for a while. So what I've done is I have put a good squirt of dishwashing liquid in, and can you see all the foam rubbers, all the soapy suds have all sort of died down. I've drained it out through the hose here, and I'll just give it a rinse off. Now, what I'll also do is, once I've got it ready to drill holes, I'm just being really cautious. I'm not doing any welding, I just want to drill holes. I'll put some water in anyway to reduce the volume, so that there's less volume for less volatile mixtures which could just explode, if a spark is created. So the idea is to, on the underside here, is to make a 7 or 8mm hole, and then I've got a tapered pin which I'll push into the hole and work around, which will fold the hole into the tank. And then what I'll do is I'll run a tap down that folded in bit of sheet metal, and screw the little fitting I've got into it, complete with a bit of Araldite to fix it and seal it all up. Basically what I'm going to be doing is making a sheet metal nut from the underside of the tank, which this fitting will screw into. They're used in military applications all the time, so I don't see a real problem with it. Although, as was pointed out, those sheet metal nuts are typically superior quality material than what this tank is probably made of. The fitting I have lying around is this one here. Now, it just happens that it's a good fit for the fuel line, which I'm going to use as the breather for that mid tank. And the threaded portion here appears to be 1/8 BSP, so quite an odd size, but it just turns out that my mate Kevin has the exact right taps, and I spun this up on the lathe today at his place. So I'll drill a hole that's somewhat bigger than this end but smaller than this, and then I will tap this device into the hole, and might have to work it around a bit, you know, give it a bit of a wriggle, bit more tapping, bit more wriggling, a bit more tapping, and that will fold the edges of the hole in. And once I've got it up to this parallel section here, that'll be the correct tapping size to use for 1/8 BSP, which is, it's about 9.6 to 9.8 millimeter, depending on whether it's parallel or tapered. Odd thread size, but we'll make it work. I've now threaded the hole and screwed the fitting into the side of the tank. Now, this shows it with the Araldite, which is still wet, just waiting for it to dry. So I probably won't do anything to it until tomorrow morning. Actually, probably not even tomorrow morning. I've got a engineering show to go to tomorrow morning. The eagle-eyed among you will spot the mistake. Bit embarrassing, but there you go.